Everyone, so this is me taking you through question 3 from the homework. I'm just going to quickly knock up a solution. Okay, here we go. We've got an inclined plane. And even though it's drawn for you in the question, draw it again. It just means you can make the diagram a little bit more clearer. I mean, I hate, for example, drawing the object as a ball, which is obviously just going to roll down the plane, so I prefer to draw it as a block. It's little things like that which I think can make a real difference. We've got a force over here at, what is that? That's 36 newtons, so we'll stick that on there. And that's all they tell you. You've got to put all the other forces on. We do know that's 30 degrees. Now, the other forces, well, you've always got weight. Weight's pretty easy. It always goes directly down towards the center of the Earth. And the weight here, as we're told that it's 4 kilograms, that's going to be 4g. And we also know with the weight that that angle here, which is 30 degrees, is always going to be exactly the same as this one, which is also 30 degrees, yeah? Okay, great, so we've got the weight on there. Now, another force which is frequently forgotten about or ignored, even though it's very important, is R, the contact force. The reason it's important is because it's really useful with the friction. F equals F max equals mu R, and so you can't deal with friction if you're not looking at the value of the contact force R. R changes according to the friction. You'll notice as well I'm doing these little funny triangles because I'm trying to make sure that every single force arrow can be resolved into parallel to the plane and also perpendicular to the plane, because I'm going to come up with those two equations. And if you get those equations wrong at the start, it all goes tragically wrong for you. But if you get it right, then it all goes very right for you. And that's the nature of mechanics questions. It's big marks, but it tends to be you get it all right or you get it all wrong. Okay, have we got any more forces to think about? Well, the plane is rough, and P is moving up the plane at a constant speed. Okay, so the plane is rough, so we need some friction. And if it's going up the plane, I guess the friction is going to be going down the plane. I often call it F max just to remind myself the friction is at a maximum. How do I know the friction is at a maximum? Well, because it's moving. Any object which is moving, the friction must be at a maximum. However, it is going at constant speed, so the forces will still balance. It's when it's accelerating that one force is larger than another. If the forces balance, if the object is going at constant speed, the forces will balance. Okay, we don't know mu, so I'm just going to put mu equals question mark. I think we find that in part B. But in part A, all we've got to do is find the magnitude of the normal reaction. Now, the normal reaction is going perpendicular to the plane, so it makes sense to look at those forces first. Now, what forces have we got going up in a perpendicular sense to the plane? Well, we've got R, and we've also got 36 sine 30. That should equal the force going down in a perpendicular sense to the plane, and that's going to be 4g cos 30. As you can see, I've only got one unknown there because g is something we know. So now I'm just going to work it out on my calculator. 4 times 9.8 times cos of 30. Make sure you calculate as in degrees. And then take away 18 because sine 30 is a half. And we end up with 15.95 newtons. Or 15.9, 15.95 newtons. Let's say 15.9 and work to 3 sig fig. Okay, we've now got to find the value of mu. Now, that means that mu is obviously, F max is mu r. So we've got r, we need F max, then we'll be able to find mu. How are we going to find F max? Well, by considering the other direction, the lefties and righties parallel to the plane, if you like. Now, here we're going to have F max plus 4g sine 30, because they're both going down the plane. Well, that's going to equal 36 cos 30. And that allows me to find F max. And here F max is going to be 36 cos 30. Let's just quickly work it out. Minus 2 times 9.8. I get 11.558 really there. And so mu is going to be that divided by 15.9. And I'm getting 0.73 really there. And so that's B done. So that was A. and this was B. Now we've just got to do part C. The force of 36 newtons is removed. Now, my advice to you here is to honestly draw the diagram out again. Don't be lazy. Draw it again. Pick up the pencil and draw it again. If they change any of the forces on the diagram, don't think you're clever enough to just ignore it. You're not. You need to draw it again. So let's draw it again. Okay, so we've not got the 36 newtons anymore. We've got the R. We've got the 4G going down. Now, think to yourself, is this going to change things? Is friction still going to be going in the same direction as before? Friction was going down before because the object was going up the slope. But if you remove that 36 newtons, well, the object isn't going to go up the slope on its own, is it? But it is all of a sudden removed. So we've got to find, I'm just reading the question properly now, we've got to find the distance that P travels between the instant when the force is removed and the instant when it comes to rest. So it will still be going up the slope, but it will be trying to go down the slope in a sense. So we're going to have the friction still coming down here. And that's because you've got to think, well, it's just literally been removed. So what's going to happen to the object is it's going to travel up and then start traveling back down. But on its way back up, it's when it gets to here at the peak when it will be coming to rest. We call that instantaneous rest, and I'm a little bit disappointed that the question doesn't make it clear that it is an instantaneous rest there. But we're going to find that distance. So how are we going to find that? Well, what we want to do is really going to be kind of a SUVAP problem, really. We know that the initial speed is 16 meters per second just before it was removed. The final speed is going to be 0 once it gets to here on its path up before it goes back down again. And we need to work out the deceleration, therefore. Now, that's an F equals ma problem, yeah? And we can say, well, minus F max equals the mass, which is 4, times by the acceleration. Oh, hang on, I've forgotten about the 4G as well. Sorry, there we go. I'm messing it up myself, this question. Always happens. Okay, we can say that minus F max minus 4G, oh, I haven't put the 30 in there, sine 30 equals 4a, which means I really need to work out what F max is. Well, F max is mu, which I've already worked out, times by R, which is going to be 4G cos 30. Notice that's changed. That's not the same as before the R. So that changes everything. And that's going to give me, let's just quickly work that out. I'm using the full version of Fmax here, so I might have a slightly different answer on my calculator to you here. Cos 30. And I get 24.64. And hence, minus 24.64 minus 4 times 9.8 times sine of 30 equals 4a. This should be negative because I'm expecting a negative acceleration. So minus answer minus 4 times, well, just 2 times 9.8 because sine 30 is a half. And then divide it by 4. Okay, I'm getting minus 11.06 here for the acceleration. And now it's a SUVAP problem. I've got U, I've got V, I've got A, and I'm looking for S. Well, that's V squared is U squared plus 2AS. And so naught equals 16 squared, 256, minus 2 times 11.06 times by S. And that gives me an S value of 256 divided by 2 times 11.06. I'm getting an answer of, oh, I've typed into my calculator wrong. 256 divided by, you know when you see an obviously wrong answer, that's what just happened to me. Okay, I'm getting 11.6 meters. Okay, hopefully that was useful. I hope you found yeah, the video useful, and that's all there is to it for today. Okay, well done. Bye bye.